Hello and welcome back. Let's do a proof. So we are given, prove that if two lines are perpendicular to the same line, then they are parallel to each other. Okay, so we have three lines, A, B, and C. A is perpendicular to L, B is perpendicular to L, and we need to show A and B are parallel. Okay, so first let's mark up our diagram to reflect what we were given. If we know that excuse me, line A is perpendicular to line L, that means right angles are formed here. Around this point, let's call it C. Same thing, if we know B is perpendicular to L, then we know right angles are formed here. Call this point D. And since we're talking about angles, let's add a couple more points. We can say M, N, P, maybe we'll throw in a Q and an R here. Okay, so why did I do that? Well, how do we prove that two lines are parallel? We have to do one of two things, either show that alternate interior angles are equal in measure, or that corresponding angles are equal in measure. So we can see in our diagram, alternate interior angles would be, for example, these. We can see they're 90. We can also say these are corresponding angles, and there are a few pairs of those. So this should be pretty straightforward since they're all 90 and they're all equivalent. So let's start writing in our proof. Let's say for number one, we start with what we were given, that A is perpendicular to L and that B is perpendicular, to L. Given. Number two, we want to explicitly name some 90-degree angles. Let's say I want to mention those two. So that would mean angle AC, let me trace it, ACP is a right angle, so it's 90 degrees. Measure of angle ACP equals 90 degrees, and, well no, let me keep it separate. Perpendicular lines form 90-degree angles. Perpendicular lines form, let's say, right angles. And then let's have the next statement be that the measure of angle BDQ is equal to 90 degrees for the same reason. And if this is equal to 90 and this is equal to 90, then obviously they're equal to each other. We can say by substitution. So let's write that down. That the measure of angle ACP is equal to the measure of angle BDQ by substitution. Let's go back to our diagram. Where are these angles? ACP is this angle, and BDQ is this angle, so they are corresponding angles, and they are equal in measure. So our final statement will be that A is parallel to B. The reason is if two lines are cut by a transversal, if two lines are cut by a transversal such that corresponding angles are equal in measure, then the lines are parallel. And we're done.